Hello and welcome everybody to the tutorial regarding assignment 6. Sorry, I was not able to take the class yesterday because of power issues in Bangalore. It's been flooding here, and because of that, there are certain problems that people here are facing. But anyway, let's just move on to the assignment itself. You can always ask questions regarding this on the forum or in the next tutorial, that is next week at Tuesday 6 p.m. as well. Okay. Uh, yeah, with that, let's start with the assignment. So the assignment was reasonably okay. It was more of again concepts and a little bit of calculation. Okay, so let's jump into the assignment itself. The first question was, what happens to the variance of a sample when the sample size decreases? And the answer to this is that when sample size decreases, the variance increases. Okay, remember that uh, variance is inversely proportional to sample size, and when sample size is small, your variance becomes large. So yeah. Next question is, what is the minimum size for a sample to get a normal distribution in the case of a symmetric and non-symmetric population distribution? And the answer to this is, for a symmetric distribution, you just need two samples. From that, you can derive the standard deviation, mean, and everything. And because it's symmetric, it looks like a normal. Okay, you can define it just with the mean and standard deviation, which are parametrics of a normal. And for a non-symmetric distribution, the minimum sample size is 30. This is just a rule of thumb. It's not mathematically exact, but it's just a rule of thumb that for non-symmetric population distributions, a minimum sample size of 30 can help you attain a normal distribution, but this is the minimum size. That does not guarantee that you will always get a normal distribution if you have just a sample size of 30. The more the merrier, but this is just a lower limit to that. Okay, next question is, if a sample of a population, if a sample population of size 36 is selected from a population with mean 100 and standard deviation 15, what is the standard error of the sample means? For this, it's all you have to do is use this formula, that standard error. So the standard error of the distribution of sample means is nothing but sigma by square root of n, where n is the sample size and sigma is the standard deviation. And the given standard deviation is 15, and the sample size is 36. So if you substitute those in the equation, you get 15 by square root of 36, which is 15 by 6. And if you calculate that, it comes out to be 2.5. It's fairly simple. So standard error is nothing but sigma by square root of n. It tells you how the standard errors are distributed. That is all it tells you. That is what you mean by standard error. Maybe in the next class, I'll ask one of you to give me a more literal meaning of what standard error is, what the actual definition in English is. Maybe, yeah, let's see what you guys think of it. The next question is, given a standard deviation of a population is 60 and the sample size is 25, what is the standard deviation of the sample? So this again, so you know that the standard deviation of a sample is this, x minus the mean of the sample and the square of that, and you need to sum over that. And in the denominator you have n minus 1, whereas in the population standard deviation, it is the x size minus the population mean squared, you sum over it, divided by capital N, where n is the size of the population itself. So what we have here is that The sample size is 25 and the population and the standard deviation of the population is 60. You can substitute if you substitute instead of 25 you substitute 24 in the denominator for n minus 1. So n here was 25, right? In the question you have n is 25, sample size is 25. To get the population standard deviation you just have to make it 24, and 60 by 24 and yeah, so if you just do that as 24 and you see it won't make a lot of difference between this numerator divided by 25 versus this whatever divided by 24 and the square root of over that, it will remain almost the same. So both the standard deviation and population mean will be 60 for a sample size that's as large as 25. Okay, so all you have to remember here is that both population standard deviation and standard deviation of the sample will be nearly equal if not equal when the sample size is pretty large. 25 is large enough here. The next question is, given your hypothesis, null hypothesis mu is 20 and your standard deviation is 4, you get a sample mean of 21.4 for a sample size of 36. What is the test statistic? And for that you need to use this formula, that is the z statistic is mu minus the sample mean. Mu is and yeah, the absolute value of this, yeah, uh, divided by sigma by square root of n, where n is your sample size, and when you substitute the values you get 21.4 minus 20. 20 is your hypothetical mean. I've just interchanged this, maybe I'll write it the same and then I just interchange this just so that there's no more confusion. Yeah, the absolute value of this, that is the hypothetical mean minus the sample mean, that's 20 minus 24, absolute value of that, divided by sigma is given, it's 4, divided by square root of n, and you know the sample size is 36. So if you just simplify this you get 1.4 divided by 4 by 6, and when you simplify this you get 2.1. So the statistic for given a standard deviation of 4, sample size of 36, and population, the hypothetical mean to be 20 and the sample mean to be 24, 21.4, you get the set statistic as 2.1. The next question is given again hypothetical mean of 34 and sigma equals 5 and a sample size of 100. The standard error of the sampling distribution is, again we have done this before, standard error is nothing but sigma by square root of n. Sigma is given as 5 and n is given as 100, that is the sample size. So 5 by square root of 100 is nothing but 5 by 10, which is equal to 0.5. The next question is, a researcher wants to obtain an estimate of an average level of some enzyme in a population and takes a sample 10 individuals, that means the sample size is 10. Determine the levels of the enzyme in each and compute. He determines the level of the enzyme in each and computes a sample mean of x equals 22. So sample mean is 22. What is the 95 confidence interval of the mean, given that the distribution is normal and has a variance of 45? For this you just need to again substitute values in a formula, and the formula is this. For standard for 95 confidence intervals, this is a formula, that is mean plus or minus 1.96. This value is important here. So for different level percentage of standard confidence intervals, like for example 60%, 95%, 99%, and so on, this value will change. So for 95% the value is 1.96. into the standard error. And then I'll maybe in the next class, one of you can tell me what the particular values for say 95% and 99% confidence intervals, and even what 68% confidence interval, what the coefficient, like what this number is. Okay, I'll ask you that in the next class. But yeah, so for 95% confidence interval, the formula is mean plus or minus 1.96 times standard error. And then for to calculate standard error, you just have to calculate sigma by square root of n. But in this question, we have variance. So variance, the relation. To get the standard deviation from variance, we need to take the square root of that and then divided by the square root of n. So this is nothing but square root of the variance, that is 45 divided by square root of uh, sample size. So it's square root of 45 by 10, which is square root of 4.5, which is nothing but 2.12. And then 95% confidence interval is nothing but mean plus or minus 1.96 times the standard error that we found. And when we do that, it's 22 plus or minus 1.96 into 2.12, which gives us 22 plus or minus 4.16. So the 95% confidence interval is 17.84 to 26.16. This is very close to the answer as given in one of the options, which is 17.76 and 26.24. Actually, when you substitute instead of 1.96, if you take 2, if you approximate this to 2, you get the exact values in the given in the option, that is this. But this is more accurate at what I have done here, which is basically use 1.96 as a coefficient. But yeah, you can also write this as 2 into a standard error and calculate, and you will get exactly this answer. And then the thing, next question is central limit says that the sample distribution approaches normal if, and the answer to that is if the sample size is large. You know that when sample size is 10 to infinity, any distribution tends to become a normal. This comes from the central limit theorem. For the last answer, the which of these is not true for mean of the sample distribution? Actually, I don't know the answer for this because I don't understand all the options currently. Maybe you can write in the forum. For me, I don't understand what the mean of which statistic is. For example, I don't know what mean of the statistics of all sample distribution. What is this statistic? I'm not very sure. So yeah, I don't know the answer to the last question. Maybe you can ask it in the forum and you might get a reply. But I'm not so sure about this. But regarding other questions, if you have doubts or clarifications, please do ask them in the next class, that is on Tuesday, 6 p.m. Until then, yeah, please do focus on the assignments and the course itself and let me know if you have any doubts regarding it. Yeah, thank you so much and bye bye.